To train modern AI, a single graphics processing unit is useless. These systems require tens of thousands of chips operating simultaneously as a unified cluster. As data travels between chips through traditional copper wires, it generates severe electrical friction. The signal degrades. At 1.6 terabits per second, copper melts down. To move data without catastrophic heat, manufacturers must transmit signals using lasers over fiber optics. Computational growth now faces a hard barrier in data transfer physics. The specialized hardware required to solve this optical bottleneck is produced by Lumentum, a hardware manufacturer that survived the deadliest tech crash in modern history. This chart tracks the stock performance of JDS Uniphase. During the peak of the dot-com bubble, the company was valued at over $100 billion. Within months, the bubble burst, the market cap crashed 95%, and 16,000 employees were laid off. To survive the next 2 decades, the company applied its optical engineering to low-profile applications. They manufactured complex color-shifting inks for physical currency and developed the tiny, precise lasers used for Apple's iPhone Face ID sensors. By 2015, this survival period left the company with a massive, debt-free manufacturing footprint specialized for high-precision laser production. This schematic maps out a new architecture called co-packaged optics. To save power, engineers move the optical transceivers, the modules that turn electricity into light, off the edges of the server rack and onto the central GPU package itself. However, lasers generate extreme heat and are prone to failure. If they sit directly on the hot GPU core, they break. To fix this, engineers extract the laser emitter into an isolated module that feeds light back into the system through a fiber connection. Lumentum specializes in the production of the specific hardware needed for this task, continuous wave lasers built from indium phosphide. These materials allow the laser to output massive amounts of light without buckling under the thermal stress of a data center environment. This graph demonstrates a secondary problem: optical noise. High-power lasers naturally jitter in frequency, called line width, and fluctuate in intensity. If a laser is noisy, AI data is corrupted. Lumentum produces the only independent laser diode capable of hitting ultra-high power while maintaining a stable, razor-thin line. Lumentum holds a near monopoly on the precise optical physics required to keep AI data centers from turning into noise-filled furnaces. Most modern tech giants design hardware but outsource the actual manufacturing to foundries. Lumentum physically owns and operates its own fabrication plants. In 2026, the global demand for high-quality photonics is outpacing the physical supply by nearly 30%. The dot-com fiber bubble was built on speculative capacity. Today's AI boom is a reaction to a mathematical wall. The chips are already built, and they are choking on the thermal limits of copper. While NVIDIA provides the processors, Lumentum provides the light. Without this specific laser architecture, high-density AI clusters go dark.